why first of all these two technologies were there, stateful and stateless, but if you go to internet, who is writing the article, from where that knowledge is coming, all are random, and the more you'll read about it, you get confused. What is written here? What is written there? Correct. So I'll give you the simplest example. At your level, you will be able to explain it. This is the whole idea of stateful. So let me see if you can see the screen. Let me share my screen. Yeah, this is most important question, by the way. Okay. There's very high chance that they will ask you when you learn firewall. The first question would be stateful versus stateless firewall. Can you see the screen?
Yes.
A stateful firewall. Okay. This concept was actually launched by a company called Checkpoint. They claim that they are the first company in the world to create this concept of stateful firewalls. It's a patented technology. Correct? I think it 90s, I guess 94 or 95. This company, created this technology. So since it's the old technology, common sense says that all new companies today, PAN, Cisco, Fortinet, and all other companies like Zscaler also to a certain extent, like there's a cloud-based firewall, right? They all use this stateful concept. For example, firewall is a very simple concept. What is the concept of firewall? You receive a packet, there is a rule, apply it, drop the packet, accept the packet, move forward. This is firewall, correct? Now this concept, which I explained to you in a plain English, if you go to the deep packet inspection, next generation firewall, third generation, fourth generation. So people will keep using different kind of terms to arrive at certain kind of skills or topic or a point. But the fundamental concept of stateful remains the same. If you understand that logic, then top of it, everything else will be built, whatever you are trying to read, and then see whether it is making sense or not. Is it clear? So the first thing first, stateful inspection is little older kind of concept. Still, people are trying to evolve from it. PAN is a company which says that we are doing next generation firewall because we are adding users, IP, and everything else. But at the core level, the concept is stateful. And why this was launched? It was launched before stateful. All the other firewalls were stateless. Stateless means no idea about communication. Right? No idea about the communication going on. So let us understand this idea with a diagram. So you have a source. You have a firewall, right? And you have a destination server. And you want to open the protocol called HTTP. Understand the story. So 1990s, HTTPS was not there. Everybody is HTTP. You are a source here. You have an IP address 10.10.10.1. Okay, and the server is public IP address like 20.20.20.20. You want to open this HTTP connection. Your packet starts from here. This is your source. You want to go here to as a destination, correct? The packet which leaves this NIC card. What will be the source IP address on this NIC card? Tell me. What will be the source IP address of the packet which leaves the NIC card, the Ethernet card of this particular source? What will be the source? 10.10.10.1 is a source, right? What will be the destination? 20.20.20.20. What will be the source port? Source port number.
Any. It will be.
It could be
random.
any random by operating system. Operating system will assign some random number. It will always be more than 1024 number. So it will always be 1025 and above. Generally, it is like in 5500 like this, such big number. The maximum number it can go is 655, 35. 2 raised to power 8. If you add, this is the number you will get. OK. Now, any number you will be able to assign by the operating system. What will be the destination port in this example?
80.
Port is 80. And then protocol, application layer protocol.
HTTP
is a TCP. No, sorry, transport layer is HTTP is an application layer protocol. At transport, it is TCP, right? Source IP, destination IP, source port, destination port, and the protocol. This packet leaves it and it hits here inside interface. OK. Now in the firewall, you have a lot of rules created. OK, a rule number or access list, rule number 1, rule number 2, rule number 3, right? You go one by one. It starts from top, go to the second, go to the third. In rule, what do you configure? You configure source IP, destination IP, you configure port, sometimes you configure zone, depending upon what product you are using, and then you configure whether to accept the packet or drop the packet. Is it clear? Any doubts here?
No, sir.
So the packet hits the firewall where it will start looking at this rule. Shall it start with the last rule, random rule, top rule? Generally, it starts at the top.
So it goes sequentially from top.
OK, it goes sequentially from top to bottom, the way you have configured it. If your rule, top rule says any source, any destination allow, so irrespective what you are typing in below, it will not matter. Similarly, in access list, if the access list top rule says allow, then there is no point of configuring drop, right? So it will check this rule. It will check source port 10.10.1. Suppose the rule says 10.20.30.x is allowed to 20.20.30.x on port 80, and you say allow. So this packet is coming to the firewall. Will it match this rule? Yes or no?
Yes, sir.
This packet 10.10.10.1 2020 will it match this rule which says 10.20.30.x trying to go to 20.20.30.x?
No, sir.
It will not
No,
match.
sir.
10.20.30 is different than 10.10.10. Correct? If it is a network 10/8 10.0.0.0, then it will match because it belongs to the same network. Is it clear?
Yep.
But here it will not match. Source is not matching, destination is not matching. Since it is not matching, it will check the rule number 2. Rule number 2 says 10.10.10.1 and destination is 20.20.30.x, port number 80. Will it match the second one?
Yes, sir.
No, sir.
No, sir.
It will not match because 10.10.10.1, 10.10.10.1, okay. But destination is 20.20.20.20. Here it's 20.20.30. It will not match. Correct. In order for a rule to match, it has to match the source IP, destination IP, port. We have not reached till port. One of the things is not matching. So if it is not matching, whatever is written here, I don't care. I go to rule number 3. or rule number 4, whatever, right? This rule says 10.10.10.1 trying to reach 20.20.20.20 port number SSH 22 allow. Will it match?
No, sir.
No, sir.
No, sir.
Why?
The
Port number
different
different.
number.
This matches,
Both.
but this is not matching. Then it go to the next rule. This is 10.10.10.1 20.20.20.20 port 80. Here it says allow. Will it match?
Yes, sir.
Yeah.
Yes, sir.
Now it
Yes,
will
sir.
match. Okay. Once this packet is matched inside the firewall, right? Ingress, when the packet is received, you are processing this. Now you have to release the packet to the external interface, correct? Here, you have to release the packet. Before you release the packet on the external interface, do you think as is I should release the packet or I should modify something in this packet? Tell me.
Now it acts as a source, sir.
What?
Now destination act as a source.
Destination? No. I'm asking packet is still, it has received here, processed. Now the packet has to leave the firewall for the next device till the destination part. At this stage, when it has to just release the packet, will it modify this packet, which looks like this? Will it modify? Yes or no?
No, sir. No, sir.
It will not modify.
Netting is not done, sir.
Netting will be there.
In the real world, whatever you have studied, it will modify the source IP address because this is a private IP address. Any private IP address, if it is internet, assuming we are accessing Google, and if netting is mandatory because with this source IP 10.10.10.1, you may be able to reach the destination, but reverse packet will never come because it's a private IP address. So what your device will do is it will change this source to a public IP address, which is generally in the firewall is the external interface IP address of this box generally. But sometimes it can be other also because the job of this firewall is also to apply rule plus NAT. Both it will apply. So this particular IP address, okay, is converted with the external IP address of this box. Okay, because this side is in LAN, which is local. This is WAN, which is public. But sometimes when you are working in BT, you may come across many firewalls where the LAN side, WAN side, both are private. Because this firewall is connected via some cable to an external router, and router is actually connected to ISP, to the internet. So here is public. For firewall, LAN is internal, WAN is also internal. So concept of netting, though it says private to public, but it can be applied on public to public, private to private, does not matter. The objective of netting concept is before I release the packet, shall I change the IP address, source or destination or not? That's the question it will ask. If the configuration is done that yes, you should apply, then it will go ahead and do that. Why it will apply? Because this is private IP. So this will be changed to public. Suppose the public IP, keep it in simple network. Suppose this is also in 20 network. So this will convert into 20.20.20.1. Everything else remains the same. Second thing it will change is this source port. So it is creating a NAT table. This table is called NAT table, right? This is before and this is after. Before my packet look like 10 is the source, 20 is the destination, OS, whatever has given you the port 80 TCP is my before. And after it will change it to this IP. This will remain the same. This will be some randomly generated source port by the firewall stored here. And then this packet will be released on the cable, physical cable to the destination. This is how the packet will reach the destination. And when the return packet is coming, okay, when the return packet is coming, again, it has to go through all the rules. Those days, there were no rules, there were access list. On router. Since these devices don't hold any data, the packet will come, again it has to go through the same process. What is the rule number 1, rule number 2, rule number 3? You know, and the packet will be accepted. Somebody will argue that yes, then data is already there in the NAT, so packet will hit it and I will be able to accept the packet and will be able to move on. And this particular requirement of storing this information while going the forward and coming it back was the major reason why firewalls are not scaling. Network layer device were only able to look at the IP addresses, and the application layer, which is looking deep inside, whether you are sending a PDF, whether you are sending Word document, whether you are sending a malware, you are writing a script, which is always there on the application layer, visibility, you'll not be able to scale it. So Checkpoint as a company came up with the concept to solve the speed of this issue, that every time I'm going, I'm checking the rules, coming back, I'm checking the rules, and very difficult to create products which will match both the rules, both the sides. This checking the rule base every time. Okay, when the packet is coming is generally called stateless. Stateful firewall is along with this NAT table, which is a mandatory. Suppose there is a firewall where NATing is not required, so this table will not be there. You create another table which is called state table. And that is the word state table is the reason why this firewall is called stateful. So what Checkpoint told is that let us maintain this communication inside the RAM. And what will be maintained? First packet hits the firewall, check all the rule base. Once the packet is allowed, you made an entry here. For you from the interview perspective, just keep it simple. Don't go too in depth. You keep at least these mandatory information: source IP, destination IP, source port, destination port, and protocol. These 5 entries you keep it in the table. And keep it. There is a timer for all these connections. Whatever connection I have added it here, there is a timer in the RAM. It's a 60 seconds or 60 minutes. This will be different from different firewall. Cisco may have it 60 seconds, PAN will have 60 minutes, does not matter. One entry is made, there is a life of this entry. So what happens? First packet for your computer reaches the firewall. Firewall check all the rules, process it. Once it allows the packet, an entry is made inside the state table, which is stored in the RAM. So there is a command available on all these products to check the state table. I can demo you on Checkpoint. I'll show you how to check the state table of my Checkpoint firewall. How does it look like? Similarly, you should be able to check state table of FortiGate PAN. I will check and I can let you know by tomorrow as well. We'll be able to see the state table. Now, what is the advantage of this state table? Entry is made here. In stateless, the issue was when the packet is coming, again, I have to go through all these rules. So I have to create 2 rules, forward and backward, both. If any change in the source and destination port, like FTP protocol, it works on 2 ports, 20 and 21. 20 is generally started at the server level. At server, you start with 20 and come back to the client. Now rule says 21 is allowed. You are coming from 20. Obviously, this firewall will not work, the stateless firewall. But in stateful, the way it is designed, It understands it both are same. For FTP, for HTTP it is 443 HTTPS. For HTTP is port 80. These entries are made in state table. When the packet is coming back from the server, it will not check this rule base. Because these rule base, which I gave you the example earlier also, in one of the banks where I've seen it, 15,000 rules were there. Any packet which is going forward, coming back, looking at all these 15,000 or 13,499, it matches the rule. Backward and front wise, when the packet is reaching, it is always difficult, correct? You will never do that because these entries are made inside the state table. That is why it is called stateful. And when the return packet is coming, it will match the entries inside this table. And these entries, it is one entry for one firewall. When these entries are made 1 million, 10 million, these connections are called concurrent connections. And you will see on the internet, people will sell their product saying that my firewall supports 10 million concurrent connections. Literally, they are saying that my RAM on my firewall can have 10 million these entries. If it is more than that, the CPU RAM utilization already 100%. I will not be able to handle it. Software wise, it can go 100 million also. You don't need any change. We're talking about the entry inside the state table. When the packet comes, it matches the RAM. Since it is in the RAM, it doesn't have to check in the rule base. It is much, much faster. And it need not have to go through the rule. Why? Because you have already allowed the packet. Why to check it the return packet? Why you should check? There is no need to check the packet, right? If the firewall says it is allowed, return packet should also be okay. It checks the RAM, not the table. And this table is called state table. You will see all these entries. There is a life of these entries in the state table. It keeps coming like in any company, you have 10,000 employees. Somebody is coming in morning shift, night shift, afternoon shift. You open some website connection, it will be there for a few minutes. It will go out. As an end user sitting here, you have no idea what all these things are happening in the background. And you should not care also, because for you, microsecond, you will find a difference. Not even that. Because the delay is not in the firewall level. Delay will be at the ISP level. If at all there is a delay, because connectivity from your computer, your Wi-Fi to your router is all how much? 100 Mbps, more than that, right? Connectivity here is very good. The bad connectivity happens at the internet level. So you will never see this. All these things are happening in the firewall end. This concept of receiving the first packet, analyzing it, and putting a state table entry inside the firewall for a few seconds, depending upon what is the default setting of a particular product, and matching the return packet on this connection table rather than on checking at the rule base. This concept is called stateful. Why? Because the CPU cycles required to check a rule base versus CPU cycle required to check the connection table. This is very fast because you may have 15,000 connections, right? But not all rules are hit at the same time. Some rules are not in use. Some are less used. And that is one of the reasons a lot of time on firewall, optimization, customer says that the top utilized rules, highly utilized rules, that should be kept on the top or it should be at the bottom.
Top, sir.
Top, sir, top.
It should be on the top. The order of the rule matters.
Yes, sir.
Yes, sir, as it is sequential.
Correct. It checks on the sequential part. Some vendor says that it only matters once. And once the data is there, we also bifurcate inside the zone wise. And then when the return packet comes, we take care of that. So that's a different part. But you also believe we're talking about the first packet. First packet is received by firewall. You have written 10,000 rules. it has to start somewhere, right? That is why you have rule number. Some firewall would say they will look at the zone. If you have divided certain rules in certain zone, then they will pick up the zone part first, and inside the zone they will look at the other rules. But this is absolutely, don't go into that definition of the stateful. You keep it simple as a fresher level, entry level. This is what you need to understand, that stateful firewall is nothing but a concept where the entries are stored in the RAM based on the initial packet inspection of the firewall. Once it is approved, entry is made in the state table. When the packet is coming back, rather than checking the rule base again, it is stored in the RAM, and then the data is matched inside the table and the packet is quickly processed. Some people in some documentation where the complex explanation is given, they say that stateful means you will also check the deeply all those packet what you are trying to send. But that is not true, because you still create this connection once, but if you are sending suppose a PDF packet, right? So you will create a TCP packet, TCP sync. All of you guys know three-way handshake?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Correct. You know a three-way handshake, correct? So once any TCP connection will have a three-way handshake, and once it is done, I'm just trying to. So what some of the products will tell that there is a user here. Suppose you want to transfer a PDF file via email, or via FTP, or via SSH, or whatever, right? And then there is this device, next generation firewall, and it goes to the internet. At the stateful level concept, when the packet reaches and you want to upload the data on the server. OK. And this is a malicious file. Or the reverse, you take there is a malicious user here. That will be much more easier, right? Bad user are trying to upload a file on via this firewall to a server which is hosted internally. This is your server. You want to protect this by a bad user, or you have a bad internal user trying to send some bad data via this firewall. So some of the documents will also talk about the same concept, stateful, what we have agreed. However, when the connection is established and when you are trying to send the PDF, this firewall is also configured with deep packet inspection concept, which is an IPS. It will open up every data what you are trying to send, and it will matches the signature, or it will send the logic to the cloud, its own private cloud, and ask the question, is this PDF good file or bad file? So it is doing so much of work apart from additional stuff, whether it's allowed, not allowed. Maybe firewall rule says allowed, because firewall rule says source IP, destination IP, source network, destination network, whatever, port, and allowed or blocked. It doesn't say anything else. There is no firewall rule which says it allows, but bad PDFs are not allowed. That configuration is called the deep packet inspection, intrusion prevention. Some companies will call threat prevention. These are different words which is given depending on which product you are using. But if it does this and decides that yes, the packet is bad, right? So what it will do, it will block that connection which you have allowed in the rule. In rule it says source IP, destination IP, port, and allow. Port says that HTTPS or HTTP and some file I'm trying to upload, 20.20, same example, let's keep it 10.10.10.1. You are allowed HTTP access, but inside that HTTP you are uploading a malicious file. So the moment this device is configured to look inside the packet, right, it will block it, and it will also remove the entry from the state table. This entry is gone. It will never maintain this entry here. Some definitions say that it can look into packet deep and all. Why? Because most of these firewalls which is coming in the market nowadays can do all this stuff, which was not possible in the initial level of firewalls, but used to, getting developed 20 years, 15 years back. They were already filtering the packet on source IP, destination IP, port. These are the three most component which were required to block or accept the traffic. This feature of blocking at port level is called firewall. In actual sense, this is firewall. That's it. When you look inside, what all files you are transferring it? PDF, Word document, script. That concept is called intrusion prevention system. That another product was launched. So 25 years back, this was the only product in the market. There was no other product. You can only do this, what I'm showing you. Source IP, destination IP, port, allow or block. That's called firewall. After that, another product called IPS came into picture, which will look inside the packet. See, you are allowed to access the website, but inside the website, you cannot upload inside that connection. You cannot upload PDF or virus or anything like incoming or outgoing both. That can be handled only by a product called IPS, intrusion prevention system. Now this got many names. Threat prevention, for example. Now what is threat prevention? Is basically it's a new name, but what it does, it will look deep inside the packet and check whether it is allowed or not allowed, rather than checking on the port level. Now people will combine these three stuff and call it as this also a stateful. Which is true in that sense that any packet is getting dropped, connection will not be put in the state table. But the stateful firewall is basically means that your connections are stored inside a connection table. There is a command to check into that. When the reverse packet comes, it need not have to check the rule table, and then everything is fast and you are not compromising the security at all. Now somebody will ask the question that you have this user, you have this server inside your company, and both are connected to firewall. Okay, and then this is connected to the internet. There is a malicious user here, bad user, who knows that firewall will have this entry in the connection table, right? And when I'm stating a packet, what I will do is, for some strange reason, I know the IP address of this firewall, that this firewall has tried to connect a server. Okay. So this entry inside the firewall table, source IP. This is the destination IP of the server. So entry is already there. Source IP, destination IP, source port, destination port, right? And protocol. These 5 entries are already there for this machine. There is a bad user who will try to reach the server by specially crafting a packet which will match this entry. As a malicious user, at least for sending the packet, you will be able to create a packet with source IP looks like this IP, as if it's a return packet. So forward packet is allowed, entry is made, now the return packet is coming in. Rather than return packet coming from the server, it comes from here. So if the packet comes from here, from the same entries, whatever is available, right? So we know from if it is a TCP connection, what is the first packet?
Sync.
Whenever you start a TCP, what is the first packet?
Sync.
You will always have a sync packet. There is no data, nothing. Just the sync flag is made 1. One flag, 1 bit is made 0 to 1. What is the return packet?
Acknowledge.
And then what is the third one?
Acknowledgement.
These 3 packets are first transferred. Then the 4th packet is your actual data. Okay. Now we know that any TCP connection always starts like this. And when the packet comes from a hacker, and hacker says, I'm sending this sync packet. When the hacker sends sync packet, it checks the rule base because it's the first packet. However, hacker is trying to copy this reply packet. So it will send syncag or any fourth packet, fifth packet, whatever data packet. When such packet comes, it will check the state table. But for some reason, even if it matches everything, this flag is coming from outside, right? The packet is coming from outside. Correct. And this packet says I am acknowledgement of some previous packet. This firewall will reject such connection and the error message will be out of state. Why? Because I never send any data with the sync. So you never send. There is no entry in the connection firewall. How can the first packet be acknowledgement for any packet to start with? I will never check any rule base. I first receive the packet, check if it is a TCP, I'll check with syncag or not. Forget about rule base. I'm checking at the very header level. If the header says acknowledgement, if it is acknowledgement, that means the entry has to be there in the connection table. You guys agree?
Yes, sir.
Yes, sir.
If it is
Yes, sir.
acknowledgement, means it is the second packet, third or fourth packet. It is not a first packet. If it is not a first packet, that means the entry has to be there in connection table. So I am not going to check my 10,000 rule base or 5,000 or 300 rule base. I'll just check this logic, whether the first packet what you are sending me is sync or not. If it is anything else, I will simply reject it and telling it out of state. So how you are safeguarded? You did not even check the rule base at all. Why? Because you have a concept called stateful firewall implemented on your device. So rather than checking every time every packet, looking at the very first packet properties, you can take a call whether to check the rule base or whether to check the connection table. If it is awkward packet, right? If it is acknowledgement, I will check connection table. If it is not acknowledgement, I will check the rule base. But before I check the rule base, it has to be a sync packet. If stateless firewall was there, every such packet with acknowledgement also will be received by the server. It will not block because firewall has no idea. Rule says that this server, this destination is allowed. If it is allowed, packet is also allowed. Is this concept clear now? I'm not getting into what happens at ICMP packet, what happens in UDP, which doesn't have these things. That will be out of scope at this stage. OK, focus mostly on the sync part because it's easy to explain people, but to tell them that this is what I have learned. Is it clear now? Stateless and stateful concept.
Yes, sir.
Yes, sir.
So you're not going to forget again? Because it's the most important question. And if this is where you are struggling, then there's something wrong. If you read some random content on the internet, they'll always be confusing. Just hold on, because that is what I'm telling where you exactly are acquiring the knowledge and how exactly you are acquiring the knowledge. OK, so let me share the screen with you. You guys can see the screen.
Yes, sir.
Yes, sir.
Yes, sir.
So look at the definition of stateful and stateless on a company called FortiGate. FortiGate is a top company. Look at the way they are explaining everything. Totally confusing. Stateful firewall inspects everything inside the data packet. I told you, right? If you are running IPS feature, why they are giving this definition? Because Fortinet was one of the first companies to integrate everything in a single box. And now they have changed this definition, right? So everything inside the packet, the characteristics of the data, channels of communication. These are all English. What do you mean by channels of communication? Anybody reading it, like, no, you'll get more confused than the actual definition. Stateful firewalls examine the behavior of a data. What do you mean by behavior of a data packet? And anything seems off, they can filter out the suspicious data, which I told you, right? If you are running an intrusion prevention feature also, if you are running threat prevention feature, after the firewall allows it, it goes deep packet inspection. If it finds something wrong, you will block it. So what Fortinet is telling is the most recent advancement in cybersecurity, where all the security is running on the same box and collecting it and putting it together and calling it, this is the definition of a stateful concept. Okay, stateless in a different fashion. However, you go to Checkpoint website, you read whatever I told you. It's plain and simple. When the connection is made, state is said to be established, and end of the connection, the client server will tear on and will send a FIN packet, and connection changes the state from established, right? There is a protocol called stateless, also UDP. UDP don't have a, sync and all. Whether the packet is coming from source to destination or destination to source, there is no way we'll be able to understand it, because there's no sync kind of concept, right? It's just a data. The very first UDP packet will have a query that this is my domain, please tell me the IP. The very first packet. But if it is a TCP based DNS query, suppose if it exists, because DNS also works on TCP and UDP both, it will first send sync packet, sync acknowledgement, and fourth packet will be tell me the IP address of this name. I'll send you the link for both, right? It explains certain things, right? How it comes, performance, scalable. What are the advantages? These two are important, that it is effective and scalable.